Hello everyone. So now we will start with, move on to example 3. So the problem is that an oil slick has area y equal to 30 x cube plus 100 x square meters x minutes after a tanker explosion. Find the average rate of change in area with respect to time during the period from x equal to 2 to x equal to 3 and from x equal to 2 to x equal to 2.1. What is the instantaneous rate of change of area with respect to time at x equal to t? So in the last class we have studied that average rate of change. So here you can see that y is not a linear function of x. Okay, the degree is 3. So y is not related linearly to x. So here you have y equal to f of x, and f of x is 30x cube plus 100x. Now, average rate of change is denoted by average rate of change is delta y by delta x, which is f of x naught plus delta x minus f at x naught by delta x. And f of x is this. Okay. So we have to find the average rate of change in area with respect to the time of the period from x equal to 2 to x equal to 3. Okay. So x equal to 2 is the initial one, and the change is that new one x naught plus delta x is x equal to 3. So it means that we have to find in the first case we have to find effect So in the first case we have to find f at 3 minus f at 2 divided by 3 minus 2. Okay, that is the delta x. So x naught plus delta x is 3 and x naught is 2. So we have to find the period is x equal to 2 to x equal to 3. Okay. Now this when we do, we have to substitute here f of x is 30x cube plus 100x. So this will be 30 into x cube. X is 3, so 30 into 3 cube plus 100 into 3. So this is the first quantity. This is f of 3 minus f of 2. F of 2 means you have to substitute x as 2. Okay, so it will be 30 into 2 cube plus 100 into 2. Bracket is there. Okay. Whole divided by 1. 3 minus 2 is 1. Okay. So this we can simplify this. Okay. You can do this simplification and we will get this as 670. Okay. So this is from x equal to 2 to x equal to 3. Okay. This is from x equal to 2 to x equal to 3. Now in the same way we can do from x equal to 2 to x equal to 2.1. The second part also we can do in the same way. So in that case our equation become f at 2.1 minus f at 2 whole divided by, this will be 2.1 minus 2. This is the delta x, change in x. Okay, so as x change from 2 to 2.1, the change is 0.1 here. So this we can calculate. F at 2.1 means we have to replace x with 2.1 in this equation. Okay, this is our f of x. In this replace x with 2.1. So you will get 30 into 2.1 whole cube plus 100 into 2.1. Okay, minus f at 2. F at 2 is same here, so it is 30 into 2 cube, this is cube, plus 100 into 2. Then we have the whole divided by, this is 0.1. Okay. This simplification also you can do in calculator also. In the same way we can do it. So you will get this as 478.3. Okay. So here the unit is square meters per minute. Okay. So unit is square meters per minute. So the same unit here, square meters per minute. Square meters per minute. So we found the average rate of change from x equal to 2 to x equal to 3. We got it as 670 square meters, and then we found the average rate of change from x equal to 2 to x equal to 2.1, and we got it as 478.3 square meters per minute. Now next we have to find the instantaneous rate of change. So next we have to find the instantaneous rate of change, and it is obtained by finding the derivative. Okay, so we have y is equal to 30x cube plus 100x. This is our y, or this is our f of x given in the problem. Now we can find the f dash of x, its derivative. F dash of x will be, how to differentiate this? So this is 30 into derivative of x cube. Hope you know derivative of x cube. It is 3x square. So into 3 into x square plus derivative of 100x. So derivative of x is 1. So plus 100. Okay. So 30 into 3. So this will give you 90 x square plus 100. Now we have to find the instantaneous rate of change of area with respect to time at x equal to 2. So what is instantaneous rate? Instantaneous rate is nothing but it is the limit of the average rate. Okay. So this instantaneous rate, is nothing but it is the limit of average rate. So average rate, we already know, we have calculated the average rate, and its limit is nothing but the derivative. So this is the first derivative, f dash of x. So we have calculated it. We have to find at x equal to 2. So we have to find f dash of x at x equal to 2. So substitute here x equal to 2. So you'll get 90 into 2 square plus 100. So you will get this as 460. 460. So this is 360 plus 100. So 460. Again the unit is square meters per minute. Okay. Square meters per minute. This is minute. Okay, per minute. So we have found the instantaneous rate also. So in the previous first two part we have found average rate of change, and in the average rate of change the limiting case is when delta x tends to 0. This is nothing but f dash of its derivative. So this we did here. Okay, so the problem ends here. Now we will go. So from here we see that rate of change. So if two quantities x and y are related by y equal to f of x, then the derivative f dash of x naught represent rate of change of y with respect to x at that point x naught. Okay, it is measured in units of y by units of x. This will be the unit of f dash of x naught. So in the first section we have seen that if the relation is linear, then this is true. But even if the relation is not linear, we can write the derivative. If y is a function of x, then f dash of x naught represent rate of change of y with respect to x at that point x naught. Okay. So we will see one more example here. Example 4. Question is, a circle with radius A circle with radius r millimeters has area A equal to pi r square millimeters. Find the rate of increase of area with respect to radius at r naught equal to 5. Interpret your answer geometrically. So it is given that A is, we know area A. So we can consider A, which is pi r square here. So it is given as a function of r. Okay, area is given as a function of r. Now pi is a constant. So rate of increase of area. So in the last section we have seen that rate of increase is nothing but the derivative. So we have to find f dash of r. F dash of r. Derivative of this with respect to r. Since pi is a constant, we can take pi outside. Derivative of r square is 2r. Okay. So we got it as 2 pi r. So f dash of r is 2 pi r. And at the point it is given r naught is equal to 5. Okay, r naught is 5. So when you put here, so f dash of r or f dash at 5. If you put r naught as 5, we will get f dash at 5 means 2 pi into 5. So it will give you 10 pi. So the rate of increase of area with respect to radius r naught equal to 5 is 10 pi. Okay. So also the unit will be square millimeters per millimeter. Okay. Square millimeters per millimeters will be the unit, and the value of 2 pi r. And what is the interpretation of this? Interpret this geometrically. So what does this represent? F dash of r, 2 pi r. We know that 2 pi r is nothing but the circumference of the circle. Okay. So 2 pi r is the circumference of the circle. So it means that rate of change in area is nothing but the circumference of the circle. So this is the geometrical interpretation. Okay, so rate of change in area is, so when the radius is changing, there is a change in area. And what is that rate of change is interpreted as the circumference of that circle. Okay, so we will stop here.